Okay, here's a theorem called the rational zeros theorem. We're going to use this to help us find all the zeros for a polynomial function. It says if you have a polynomial function a sub n x to the n plus da 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 down to a sub 0, then my possible rational zeros are going to be in the form p over q, where this top number is a factor of the last term, the constant term, and the bottom, the q, is a factor of this first or leading term. Okay, so it's factors of the last over factors of the first. So here's an example of what that would look like. If this is my function 3x to the fourth minus 4x cubed plus x minus 8, I'm going to look for factors of 8, which would be 1, 2, 4, and 8. They all divide in there evenly. And of course I could do plus or minuses here, I just didn't write them. And then for the 3, a 1 or a 3. And the theorem again says the last over the first. So 1 over 1, 1 over 3. And I put plus or minuses in my listing. 2 over 1, 2 over 3. Again, with the plus or minuses. Same thing for 4, 4 over 1, 4 over 3. And then last, 8 over 1 and 8 over 3. And there's our nice long list. Of course, all of these are not going to be zeros because at most we have 4, but at least I have a list of them. Now you think, well, why do I really care? Why would I want a list like that? Because if I'm looking for all the zeros, I may want to graph to kind of help get me started, and knowing what my largest or smallest zero would be is going to help me with my graphing window. And also, if the graph crosses between two integer numbers, maybe it crosses between 1 and 2, I'm not going to guess 5 halves because that's 2.5. So it's gonna help me to make more reasonable choices for those non-integer x-intercepts. Let's take a look at an example. F of x equals x to the third minus 2x plus 4. So factors of the last, 1, 2, and 4. Short list. Factor of the first, even shorter, just 1, because that's the coefficient. That's the only thing that divides into it. So last over first, 1 over 1, 2 over 1, and 4 over 4. Again, remember, they always have to have the plus or minuses with them. All right, now, the next step is actually going to be, we're going to cheat a little bit here and do something differently than our book. I'm going to go ahead and graph this. I think I already put it in here for us. So yeah, there's our function, and then I'm going to standard window, see if I can get a good picture here. And that's what I'm seeing, right? Now, the only thing off of this list here of possible zeros that looks like might actually be an x-intercept is this -2, right? So how do I confirm that? I go second and trace to get to the calculate menu, and I'm going to just check the value when x is -2. I'm going to confirm that that's a 0. Yes, because the y value is 0, I know I have a 0. Okay, so now that I have a 0, I can do some synthetic division. If I can scroll it down, I think that's enough there. The -2, now where did the rest of this first part come from? Well, remember that if you're missing a term, like we're missing the x squared here, you got to put a 0 in its placeholder. So 1, 0, -2, 4, and then we'll do our synthetic division where you drop and multiply and then add, so on. Better make sure that this remainder is 0 or you have an error in there somewhere. We started with a cubic, so that means my answer is going to be a square, x squared, minus my 2x plus my 2. So f of x is going to be our x plus 2. You're like, where did that come from? Well, if my 0 is -2, then my factor is x plus 2 times this x squared minus 2x plus 2. I can't factor that, so in order to find the other zeros and get the other linear factors, we're going to have to do the quadratic formula. Very carefully, opposite of b, plus or minus b squared minus 4ac over 2a. Okay, you get a -4 under the square root, which is going to be an imaginary number. It's going to be 2i. So we have 2 plus or minus 2i, all divided by 2. So that means each of these gets divided by 2. You don't just whack them off. 2 divided by 2 is a 1, so 1 plus or minus I. These are our zeros, so the factor is going to be x minus the 1 plus I and x minus the 1 minus I. Okay, and then we still also had this x plus 2.